So
30.
Diagram sort of stuff. Okay, let's have a look. Just so you know, question 2, which is on page 150. All right, let's go through it. So a group of 30 children are asked if they play lacrosse, basketball, volleyball, or none. The results are, you've got all those things. Draw a Venn diagram to display this information. Okay, so how many sets are we going to have in this?
3. And then
3.
like, what do you call the outside thing?
Okay,
Would
so
that
we
be
must... Universal. Venn diagrams must have the box. Okay, and there are different labels for it, but IB quite often has it with a U, the universal set. You may also see it as a fancy squiggly E shape, but it is the universal set. And basically what that means is everything that is considered in this problem will be in that box. If it's not part of the problem, it's not part of the universal set. But everything in the universal set. So in this first problem, how many elements must be in the universal set? 30. So I can write this, N, U, is 30. The number in the universal set is 30. So that means I know in that rectangle I must have 30 things. All right? And then I've got 3 sets. So I'm actually going to start with, overlap all of them. All right? Now, that might, in the end, not be necessary, but in case it is, come on. In case it is at the moment, I'm going to do it like that. Yes, T-Bay?
In the assessment, is it fine if we draw it freehand?
Yeah, it's fine.
Also, if you label do you have to have the square around it, or can you say universal?
No, it has to have the box. All right, that's an important thing. If you are, so you're going to be doing your e-assessment, and it'll probably have it all set up for you anyway. But when you move into DP and you do Venn diagrams, you will lose a mark if there's no box around the outside. All right, so it's one of those things. So we've got to label them. So we've got a set that involves people that play lacrosse. We've got a set that involves people playing basketball. We've got a set for volleyball. And we've got 3 children do not play any of the sports. So I'm going to put a 3 outside there. 2 children play all 3. So I've got 2 children in that region there. You all happy with this? Okay. 6 people play volleyball and basketball. So volleyball and basketball. So should I put a 6 there?
No.
Why not?
Because we already counted 2 out of 10.
Good. So those 2, the 6 that I'm saying is in this region and in this region. So what I should be doing is 6 subtract the 2 makes 4 people in that region. 3 play lacrosse and basketball. So I've got 3 subtract the 2 makes 1. 6 play lacrosse and volleyball. So again, 6 minus 2 again makes 4. Okay, 16 play basketball. So I'm going to write, this is just what I do. You don't have to. Basketball is 16. So 1 plus 2 plus 4 makes 7. So 16 subtract the 7 makes 9. 12 play volleyball. So volleyball is 12. So I've got 12 subtract the 10 makes 2. And that's all I've got. I've not got lacrosse. So I've got one final calculation to make, which is
add everything up.
everything. So it must add up to 30. And actually the circles must add up to 27. So I've got 27 minus, add up all of these. I've got 10, 12, 16, 18, 22. So in this it's 27 minus the 22 makes 5. So they are all my values in. So I've got 5, a 1, a 9, a 2, 4, 4, 2, 3. And they should all add up to my 30. Okay. So we say calculate the probability that a child selected at random plays volleyball and basketball but not lacrosse. Volleyball and basketball, not lacrosse. So which region are we going to consider there then? So we've got plays volleyball and basketball, so that means we're considering this region here, but not lacrosse, so that means we have to get rid of the 2, so we're only considering, the answer is?
4.
But it's a problem.
Oh, probability.
4
over 30.
30, sorry, why did I say 36? 4 from 30. Okay. What is the probability that they only play lacrosse? 5 from 30. Yeah. What is the probability that they play only volleyball?
2 from 30. 2 over 30.
Okay, now a question that's not in this one, but I want to go through with you, is what we often see in Venn diagrams is called a conditional probability. Conditional probability, and it's normally conditional probabilities with Venn diagrams start like this. Given that, blah, 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 and then there's a question. That makes sense?
Yeah.
So if I said to you, given that the student plays volleyball what is the probability they also play basketball? Yes.
6 out of 12.
So you think it's 6 from 12. What does people think?
Okay, so volleyball.
Yeah, I'm with him.
Given that this, so we already know that they play volleyball.
Yes. That's what the given that is. It's like you've already been told
Yeah.
that that will already narrow down your answers.
I'm
So
with you, man.
we are only considering now. So it says, given that the student plays volleyball. Now, suddenly that means we are not considering everything. We are only looking at that circle.
Mm-hmm.
So it actually limits now our universal set. We're now not considering 30. We are considering only the 12.
I agree.
So out of those 12, who also plays basketball?
People who play everything.
2 and 4. Which would make 6. Okay. Make sense? Right. I'm done then. Enough talking Venn diagrams. You